I saw this question on equilibrium of forces, and I would like to share it with you, my audience. It will help us revise vectors and equilibrium of forces. That said, let's get into class. Now, our question says that we have two forces, force F1, which is 8 Newton, and is acting at 60 degrees. And we have force F2, which is also 8 Newton, but it's acting at 330 degrees. Now, our question wants us to find out the magnitude of the force that will keep this particle in equilibrium. Let's take the diagram first. Now, if I have my x and y coordinate this way, here's my y coordinate, here's my x coordinate. I want us to resolve each forces, then we find the resultant. Now, for the force of 8 newtons acting at 60 degrees, I can take my 60 degrees this way between my first quadrant. So here is 8 newton, and here I have 60 degrees. Now, for the second force acting at 330, here is 120, here is 270, then here is 330. So that I have it this way too. Now, between 330 and the x-axis, I'm left with 60 degrees. That's another 60 degrees. Now, so that I have, this also is 8 newton. Sorry, between 330 and the x-axis, I'm left with 30 degrees, not 60 degrees. 360 minus 30 minus 330, that's 30 degrees. Now, so we can now begin to resolve each of these force. Let's call this F1, or let's call this F1. Let's call this F2. Now, so if I'm resolving, I'll resolve to the y component and the x component. For F1, I'll come up with F1 of y, then I'll come up with also with F1 of x. Now let's draw that out first. Now have it this way. That this is F1 of y, here's F1 of x. And here's my 60 degrees. Here's F1, which is equals to 8 Newton. And for F2, I have my x this way. Here's the force. Then here's F2 of y. And here is F2 of x. But here is 30 degrees. And here is 8 Newton. Now, if you look at it carefully, you see that F1 of y is facing upwards, while F2 of y is in the negative direction. Now, let's pick each of the components first. Now, using Pythagoras theorem, I know that F1 of y over F1 will be equals to sine 60. So that F1 of y will be equals to F1, which is 8 Newton, sine 60. From my calculator, sine 60 is the same thing as 0.866. Now 0.866 times 8, that equals to 6.928 Newton. Now F2, F1 of x, same time, will be equals to 8 cos 60. 60 is the same thing as 0.5. 0.5 times 8, that's equals to 4. That's just 4 Newton. Now, same way too, I'll be dealing with F2 of y. F2 of y will be the same thing as 8 again, sine 30. Sine 30 is the same thing as cos 60. Invariably, that's 0.5. So that 0.5 times 8 again will be 4 Newton. And F2 of x will be the same thing as 8 cos 30. 8 cos 30. Cos 30 will be the same thing as sine 60, which is 0.866 times 8. That will be the same thing as 6.928 in Newton. Now let's pick our resultant forces. Let me just create space here. Now to pick my resultant force, obviously, know that my resultant force for y, let's call that Ry. Ry, which is the resultant for y, will be F1 of y, because F1 is in the positive direction, minus F2 of y. F2 of y, that's equals to 6.928 minus 4 Newton, which is equals to 2.928. Same time, Rx will be the same thing as F2, F1 of x plus F2 of x. Why? Both of them are in the same direction. That will be the same thing as 4 plus 6.928, which is equals to 10.928. So that R now will be the same thing as the resultant, or which is the equilibrium force, will be the square root of Ry squared plus Rx squared. That will be the same thing as the square root of 2.928 squared plus 10.928 squared. Now, if you use your calculator on this, you come up with 11.31 Newton. So that the equilibrium of both forces that will keep this force at equilibrium is 11.31 Newton. With this, I hope you further understand how to work with equilibrium of forces. Thank you for staying with us, and see you in our next class.